In this video, we'll be discussing about SQL Server Query Optimizer estimates for queries with more than one predicate, and these predicates are basically joined using an AND clause. We will check like what happens as far as the estimates are concerned when we have more than one predicates and it uses an AND clause. I'm going to use AdventureWorks DW for this particular demo, and then I'm going to create a table called table1 underscore temp. And the data for table1 underscore temp will come from an existing object called table1. Now I'm going to execute this particular select query, which basically returns the count from table1 underscore temp for the predicate column 2 is equal to value Ramesh and column 3 equal to value 439. So let's execute this query with the actual execution plan. Let's look at the execution plan. What we can see is like we have an table scan operator on table1 underscore temp object. Let's hover our mouse there. And what we can see here is like we have an estimate of 7.4592. The estimated number of rows per execution is 7.4592. So what we'll do is like we will understand from where we got this value 7.4592. So what we'll do now is like we will check for the list of statistics on object table 1 underscore temp. And what we can see here is like we have two auto-created statistics that was created as a result of executing this particular query. And as soon as we executed this query, we were able to see that statistics on column 2 and column 3 is created by the SQL Server Optimizer. So now what I'm going to do is like I'm going to look at these statistics objects and then see how did we derive this particular estimate. Before that, let's look at the calculation for deriving the estimates when we have more than one predicate and it uses an AND clause. So the calculation is like the calculation is like we will basically have to multiply the selectivity for each and every predicate. So for example, in our case, what we have is like we have two predicates. So that means like we will be dealing with selectivity 0 and then on selectivity 2 for each of these predicates. The P stands here for the predicate. So since we have two predicates here, we will only have P0 and P1. But holistically, if we look at, we can have more than three predicates as far as the calculation is concerned. For example, if you have more than 4 columns in the where clause, only the first 4 predicates are counted. The calculation like which predicates will be selected, we will discuss on that. But the understanding is like if you have more than 4 columns in the where clause, then only the first 4 will be counted for this calculation. In our case, we have just 2 predicates. So the calculation basically involve only P0 and P1. So as far as the calculation again is concerned, it all deals about the predicate selectivity here. So we know that in case if there are more than 4 columns in the predicate, then we can only count the first 4 columns only. So that is the reason we have mentioned predicate 0, predicate 1, predicate 2, and predicate 3. But in our case, we just have 2 predicates, column 2 and column 3. So in this case, it is going to be just P0 and P1 only. But as far as the calculation is concerned, what we do is like to come up with the estimate for queries that has got more than one predicate. What we basically do is like we multiply the first predicate with the second predicate, and as far as the selectivity value for the second predicate is concerned, we will be doing a square root for that, and for the third predicate, we'll be doing a root of 4, and then for the third for the fourth predicate, we'll be doing a root of 8. So the SQL formula, if we look at for the whole thing, what we'll be doing is like we will be multiplying predicate 1 multiplied by power of predicate 2 comma 0.5 multiplied by power of predicate 3 comma 0.25. 0.25 is like 1 divided by 4 is basically 0.25, and multiplied by predicate 4 comma 0.125. 0.125, when you do 1 divided by 8, we will get 0.125. And once we have these values, we will basically multiply that with the number of rows on that particular table. So yeah, in order to derive P0, P1, P2, and P3, what we basically do is like we first calculate the selectivity of each predicate, and then what we basically do is like we basically put the lowest value among the selectivity for the predicate first, and then comes the next one, and then comes the next one, and then comes the next one. It is basically like we will derive out the selectivity for each predicate, and then we basically order it by ascending order. And once we complete that in ascending order, what we basically do is like we perform this calculation, we put the values and then we perform square root and root of 4 and then root of 8 based upon number of predicates that we have. So let's try that in our case. So what I understand is like we had an estimate of 7.45. So what I'm going to do is like I'm going to execute this particular query. Now this is we have run this DBCC show statistics for the statistics that is on column 2. If we see here, it is on column 2. Column 2 predicate is basically Ramesh. So let's see if it is going to be a direct hit. And once we have that, we will look at if it is going to be a direct hit. Yes, it is a direct hit. Column 2, we have a direct hit in the histogram. And the EQ rows is going to be 302. Yeah, so let's copy that and put it here. And what I'm going to do now is like I'm going to calculate the selectivity, and to calculate the selectivity, what I'm basically doing is like I'm basically picking up the row that is passing through this particular table as far as this predicate is concerned, divided by the total number of rows. So I'm just picking up the total number of rows, and then I'm going to divide that, and here comes the selectivity for predicate 1, which is your column 2. So now I'm going to do the same thing for column 3 as well. Have run column 3 here. So what I'm going to do now is like I'm going to check for the value 439. So let's see if we have a direct hit for 439. So yeah, 438. So here in this case, I don't have a direct hit for the value 438. So what I'm going to do is like I'm going to check what are the histogram steps where this particular value 439 is buried. So in my case, it is 98th and 99th step. Between 98th and 99th step is where my value 439 is buried. So now what I'm going to do is like I'm going to pick up this particular average range rows value, and then I'm going to paste it here. So basically I'm calculating the selectivity value for the predicate column 3 as far as 439 value is concerned. So how do you do that? It is basically like divide the number of rows that is going to come from table 1 underscore temp as far as the predicate column 3 is equal to 439 is concerned, divided by the number of rows that is present on this particular table, which is this one. So I'm going to put it here. So yeah, the value is, the selectivity value is this one, 0.0012. So I'm going to paste it here. So now we know that for the first predicate column 2, this is the selectivity value, and for the second predicate column 3, this is the selectivity value. So now we need to derive P0 and P1 here, because since we have just two predicates here, so we just will have only P0 and P1 here. Yep. And now in order to derive P0 and P1, what I need to check is like out of these two these two selectivity values, I need to first understand which one is lowest. I'm pretty sure this is the lowest because this is 001 and this is 002. So we know that P0 is equal to this value and P1 is equal to this value. Yep. So now what I need to do is like I need to do the calculation where. So now what I'm going to do is like I'm going to first put I think okay, this one the value is this. So P1 is this one. So if you look at it here, among these two things, this selectivity value is the lowest. So that is the reason I'm taking this as P0. Since this is greater than this one, I'm taking this as the P1. Okay. Now what I will be doing is like I will be performing I will be taking P0 first multiplied by, if you look at the calculation, this power of P1, P1 comma 0.5. So what I'm going to do is like I'm going to replace P1 with this value. And once I do that, what I'll next be doing is like I'll be taking the value of the number of rows as far as table 1 underscore temp is concerned. So what I'll do is like I will put a select count star from table 1 underscore temp. So let's execute this query. And if you see here, the estimate value that we got is 7.45. Let's look at the value there. So what we are seeing here is like we are seeing the value 7.45 and we were able to derive the same thing. So optimizer uses this complex calculation to come up with an excellent estimate as far as queries with more than one predicate is concerned. Yep, and once we have this predicate, we calculate based upon what values we have, and we calculate the estimates. And this is specifically, this demo that I'm showing is specifically for two predicates. But if we have more predicates, the calculation changes. The calculation is same. The only thing is that the formula is going to change. But as far as two predicates are concerned, this is the calculation. Just a recap. What we basically have to do is like we need to first look at how many predicates we have as far as the query is concerned, and then we need to check if it is going to be an AND. If it is going to be a OR, then it is the calculation differs, and that's an altogether different subject. But for this demo, we know like we are having more than one predicate, and these predicates are joined using AND. And now if we know that it is going to be more than one predicate and we have the AND clause used, then what we basically do is like for each predicate, we will basically be calculating the selectivity value. And once the selectivity value is calculated for each predicate, what we basically do is like we will first look at the lowest value. We basically order the selectivity values in ascending order. The lowest value will take the value of P0 and the next value takes P1. And once we have that value, what we basically do is like we multiply P0 with P1, but before multiplying P1, what we do is like we find a square root of that P1. That is basically what we do is like power of P1 comma 0.5. Since square root is 1 by 2, that comes as 0.5. So we basically do that and then multiply the resultant value with the number of rows we have on that table 1 underscore temp. What we'll do is like we will take this query up and then we execute next to our calculation. Let's enable the execution plan and then execute it. Now, if we look at the estimate here, we will see that the estimate is 7.45. the calculation that we have done is also like close to 7.45. So hence, the optimizer performs this complex calculation to come up with an estimate. For example, if you have queries that has got more than one predicate and it uses the AND clause. That's it for this video. Thanks for watching. Have a great day. Jai Hind.